Hello everyone, I am Anusha Devi. Along with my batchmates Bharat, Dinesh and Kalyani Prabha, we will be presenting about IoT based water level controller. Water is a critical resource, so there is a need for keeping a track and limit on the usage of water to conserve water. Water tank overflow is a common problem which leads to the wastage of water. Though there are many solutions to solve it, like wall valves, which automatically stop the water flow once the tank gets full. A practical way to keep track of and control the water level in the tanks is with an automatic water level controller. In the modern home, it is a need. Installing a smart water controller in your home has a number of significant benefits aside from the obvious one of conserving water and utilizing it wisely.
Regarding the block demo project, MQTT is the central part and it is interconnected with ultrasonic sensor and relay module. Relay module is connected to motor and relay module is integrated to power supply, and MQTT is communicated with adapter to MQTT protocol.
So this is our circuit diagram. The D5 and D6 pins of the node MCU are connected to the trigger and echo pins of ultrasonic sensor, and the VCC and ground pins of the ultrasonic sensor are connected to the node MCU, and the D7 pin of node MCU is connected to the relay module, and the normally open pin of relay module is connected to the motor through the power supply.
Here is the setup diagram. Here there is an overhead tank. An ultrasonic sensor is connected at the top. From the ultrasonic sensor, the level of the water will be sent to the node MCU, and according to the level of the water, the motor will be turned on or off by using the relay. The relay will act as a switch here. It helps to turn on or off the motor.
So to understand how to calculate the level of water in the tank, let us consider a tank which has a length, breadth and height of 5 feet, 7 feet and 10 feet. So here the volume of the tank will be 350 cubic meter. Normally 1 cubic feet is equal to 28 liter. So let us consider the volume of the tank to be 10,000 liters. Then for every 1 feet, the tank can hold up to 1000 liters of water. To understand the calculation of level of water, the idea we have used here is distance of water from the top will be inversely proportional to the water capacity in the tank. For example, if the distance of water from the top is 1 feet, then the 10,000 liter tank can hold up to 9,000 liters of water. So if the distance of water from the top is 0, which means that the tank is full and the water level is up to the top. Then the same method can be used to calculate the level of water for both underground tank and over the tank.
Next, let us see the distance calculation. We know that distance is equal to speed into time. Also, we have used ultrasonic sensor which uses sound waves to measure the level of water. The speed of sound is 340 meters per second. To calculate the distance, we need to convert the speed into centimeters per microsecond because the distance is measured in centimeters and the time taken by the node MCU to transmit the signal is in microseconds. So hence it is 0.034 centimeter per microsecond. Now we can calculate the distance. We have substituted the speed value in the above formula and the time is used in microseconds. Also, the echo pulse indicates the time it takes for the signal to be sent and reflected back. So to get the distance, we have to divide it by 2. So we get the actual distance. So actual distance is 0.3034 centimeter per microsecond into time divided by 2. For example, for time instance of 50 microseconds, the distance will be calculated as 8.5 centimeter.
This is the order setup for our project. Here the tank is up to 21 centimeter and ultrasonic sensor is placed at the top of it and it's interconnected with node MCU, and node MCU is connected to the Arduino IDE. Another part node MCU is connected to relay module, which is connected to power supply, and motor is connected to relay module.
Next, let us see the software simulation. We have used Arduino IDE to implement the coding part, and Adafruit is used to display the data in the server. Now let us see the software implementation of our project. We have included the necessary libraries such as an Node MCU Wi-Fi and the libraries for the MQTT protocol. The Wi-Fi name and the password are provided. Also, the credentials for the Adafruit broker is given. The server ID is io.adafruit.com and the server port is 1883 and username and the activation key are provided. Now we have created a client to the MQTT such that using the server port, username and the activation key. Now we have published the ultrasonic sensor data to the Adafruit through MQTT with the username /feed/water level detector. Also we have subscribed the on-off button for the motor from the Adafruit through MQTT with the username /feed/on-off. The trigger pin and echo pin of the ultrasonic sensor are connected to D5 and D6 respectively, and the motor pin is connected to D7. Several variables have been declared, and the MQTT connect function is used to connect the Adafruit to the MQTT protocol with the node MCU. After connecting, it will be displayed as MQTT connected. In the setup function, the trigger pin is made output, and the echo pin is made input, and the motor pin is made output. And the serial communication starts with a baud rate of 1,15,200. And the Wi-Fi is connected with the username and the password. If the status of the Wi-Fi is connected, it will be displayed as Wi-Fi connected, and the IP address of the Wi-Fi is displayed. Also, in the loop function, it should be continuously running. We will connect the MQTT protocol, and the subscription code is written here. Inside this code, if the function is called, then the motor will be manually turned on using the on-off button. Also, the trigger pin is made low. After 2 seconds, it is made high. After 10 seconds, it is made low. Within this prints, we get an echo pulse in return. So with the and the distance is calculated using the above formula, which is shown earlier. If the distance is less than 200, then we show display the distance as the 100 minus distance by 20, which is the height of the tank, and the distance is less than 0, distance is made as 0, and we will publish the distance in the serial window as well as in the Adafruit broker. Also, if the distance is less than the motor pin is automatically turned on, which will run the motor, and if the distance is greater than 70, the motor will be turned off. That's it. Next, let us move on to the Adafruit site. This is the Adafruit website, io.adafruit.com, and we have created a user and the feeds. Water level is the feed, which is used to display the ultrasonic sensor data, and on-off is the feed used to control the motors. Now let's move on to the dashboard. And we have created a water level detector dashboard. Here we have seen a gauge which will display the level of water in the tank using the ultrasonic sensors data, and the data will be displayed in the timestamp here. And this is the motor control switch in which we can manually turn on or off the motor from a remote place connected within the Wi-Fi range.
This is the auto setup of our auto director, and this is considered as a tank, and ultrasonic sensor is placed overhead of the tank, and ultrasonic sensor is interconnected with node MCU, and node MCU is interconnected with relay module is interconnected with power supply, and relay module is interconnected with motor. Initially, the water level of the tank is 0.
So the water level is displayed here as 0 in the Adafruit, and it is also displayed in the serial monitor of the body.
We also have a motor control switch here, which we can manually turn on or off the motor. Now let us turn on the motor. After turning on the motor, the water starts filling in the tank, and the value is updated here in the Adafruit window. The water level rises and the value is updated in the Adafruit window. After the threshold value is reached, motor will be automatically turned off, and it is indicated as a red bar here.